Hey, hey, hey! Welcome to Database Fundamentals. My name's Garth Schulte. I'll be your host throughout this course. We're going to put the fun in fundamentals, and we're going to learn all about databases and SQL, the structured query language, which is the language of love for relational databases. We're going to kick this course off with an introductory nugget to define what a database is, talk about what to expect out of this course, what you'll be learning, and who it's for, and then I'll get you familiar with our lab environment, the Virtual Nugget Lab. Well, let's jump in head first and get started. Now, this course assumes absolutely no database experience, the fundamentals. So, whether you're looking to become a database professional, maybe you want to be a DBA, a database administrator, or a database developer, an architect, or a data scientist, or data analyst, this is the beginning of the road to all of those career paths. So that's why we're going to start by answering that all-important question, what is a database? A database, by definition, is a collection of data organized for rapid search and retrieval. Some key words there, organized and rapid search and retrieval. Let's start with physical databases. Can you think of any physical databases out there in the world today? What about a phone book? Phone book is a great example of a database, a lot of data inside of a phone book that contains individuals and their phone numbers. And it's organized in a way that makes sense to us, right? It's organized alphabetically so we can easily find the general area where, if we're looking for something specific, where it lives, and then once we get there, again, we can find it pretty quickly. But again, this is the physical world. Nothing's quick compared to the electronic world, but it's as good as it gets in the physical world. What about a library? There's another one, right? Lots of books inside of a library, and if you walk into a library and you're looking for something specific, how are you going to find it? Are you going to go scan shelf by shelf? Well, thankfully, we would get there eventually because of the way that a library is organized. But if you really wanted to get something fast, you'd probably use index cards to point you in the specific area or general area where that book might be, and then you can start scanning from there. Again, both just examples of physical databases, and the key thing to take from that is that our data is organized in a way that makes it easy for us to find that data. Now, in today's world, when you hear the word database, you're probably not thinking about phone books or libraries. You're thinking about machines, computers with database software installed on them that host and manage all the data for an organization. Speaking of which, databases are the heart and soul, the lifeblood of every organization out there today. From mom and pop shops that store their information in Excel spreadsheets, to small businesses that use desktop database software like Microsoft Access, to medium to large companies that need full-blown relational database management systems like SQL Server to power all of their applications, to even enterprise-style companies like the Googles and the Microsofts and the Facebooks of the world that store everybody's data, usually with homegrown or open-source distributed databases that are spread across hundreds or thousands of machines. So data is important, databases are important, and data professionals at all levels are extremely important because they're the ones that are managing all of this data. In fact, this has been a very popular field since the 70s when the SQL language was created and really the relational database took off. And it's only going to get hotter as time goes on, especially with the advent of big data and that little acronym called IoT, Internet of Things, which means essentially everything is going to be connected to the internet. From our appliances to our automobiles to the clothes and shoes that we wear. Seriously, it won't be long before shoes are connected to the internet, and every step you take is generating data and getting stored in some database somewhere. Yeah, humanity's data footprint is growing exponentially every year. We're on this crazy banana curve, and we're going to need data professionals to manage all of this data. And it's a great field to be a part of. There's a lot of opportunity, plenty of jobs, and they pay well. Let's take a look at the big picture to get a feeling for all the components and players involved with a database. Let's start at the top here with the database server. So a database server is a machine with database software installed on it for creating, managing, and accessing the databases within. Another term for this software, and this software specifically here, MySQL, SQL Server, and PostgreSQL, is RDBMS, Relational Database Management Systems. And if it's not relational, you'll see the R cut off then, it'll just be DBMS. RDBMSs come with a database engine and usually a suite of tools that we'll be using to create databases and work with the database objects and data within. Inside of an RDBMS is where we will be creating these databases. And oftentimes you'll see a lot of databases packed onto one database server, right? Maybe we have departmental databases out there. HR needs a database, marketing needs a database, sales needs a database. Our products and services have applications that need databases. So yeah, you'll see lots of databases packed onto a server more often than not. Inside of a database, we have database objects. We have things like tables and views and stored procedures and functions. And these are all of the objects that database professionals, like administrators and developers, will be using to store the data as well as grant access to that stored data. We will see how to create and work with all of these objects throughout the course. So a database is really just a container for our data and all of these database objects, and a relational database management system is a container for databases. And you're going to see a lot of common functionality across all of the relational database management systems out there, and then of course they all expose their own specific features and functionality as well. As I mentioned, SQL, the structured query language, is the language of love for relational database management systems. It's been around since the 70s, and it's wildly popular because it's standardized. You'll learn it once and you can apply it to all RDBMSs out there, and it's extremely easy to learn. And it's used everywhere. Applications use it to pull data out of a database. Power users use it to write raw SQL queries to pull into their analytical tools, such as Microsoft Excel for analysis. And our database professionals, our developers and administrators, use it for both querying and to create these structures inside of the database. So we'll look at all those different layers of SQL. DML, the data manipulation language for writing queries, and DDL, the data definition language for creating these objects. So we're going to cover everything we just talked about and then some here in Database Fundamentals. On the right is our course outline. So each one of these is a nugget. And right now we are at the very first nugget, Welcome to Database Fundamentals. We'll be covering core concepts, how to write queries with the SQL language, relational design concepts, creating and working with database objects, and the basics of database administration. Now notice at the end of each one of these sections we have a lab. We're going to be utilizing the virtual Nugget Lab, more on that shortly, to provide you with an environment that you can use to get some hands-on experience. Certainly one of the best ways to learn databases, and especially the SQL language, is to get into them and write some queries. So we'll be doing plenty of that here throughout the course. So this course assumes no prior experience with databases. It really is the starting line. Once you go through this course and get some basic database and SQL skills, then you can specialize and go down any role you wish. And I should also mention, we are going to cover all the objectives for the MTA, that's the Microsoft Technology Associate for Database Fundamentals. So if you want something to show for your learning efforts here in Database Fundamentals, check out that link that will give you more information about the MTA certification and the Database Fundamentals exam. This course has an associated virtual Nugget Lab, which means you don't need your own database server and database software to learn SQL. We want you to be able to just jump right in and start writing queries and learning SQL without having to worry about your own environment. So this virtual Nugget Lab has one machine. Our database server here's name is SQL Nugget Lab. It has Windows Server 2012 R2 installed. We'll be using SQL Server 2014 as our RDBMS, and we're going to be building together a database that's known as MusicDB. This is going to be a great database to learn the fundamentals with because it's fun, it's familiar, and it's simple. A lot of the sample databases that come packaged with RDBMSs are really complex right out of the box, right? They're not very beginner friendly. So that's why I chose something that's going to be a little more beginner friendly. And of course, we got to make it fun. We're going to need to store information about artists, albums, genres, tracks, and playlists. And we're going to get to see how the relational aspect of databases plays out here, right? Because artists create albums, albums can be of a genre, albums contain tracks, and playlists can contain tracks that span albums. So it'll be great times creating, designing, loading it up with lots of data, and writing plenty of queries against our MusicDB in the Virtual Nugget Lab. And by the way, you can access the Virtual Nugget Lab on the right-hand side of the course page. In this DBT Nugget, I welcomed you to Database Fundamentals. Once again, welcome. Thank you for letting me be your guide. We're going to have a lot of fun learning about the basics of databases and set you up for a good future in an awesome field. I hope this has been informative for you, and I'd like to thank you for viewing.